Hi, my name is Herschel. In this video, I will give you a brief overview on how to create action graphs in Isaac Sim so that we can use ROS2 in conjunction with Isaac Sim. In this video, I assume you already have the USD file of the robot you're planning to use, and I also assume that you have gone through the basic Isaac Sim tutorials and know different Isaac Sim workflows such as integrated Python, standalone Python, and OmniGraph slash action graph. So before we begin with the action graphs, I will briefly go over on setting up a stage. Ideally, you would want to create a separate USD file for your world or the scene and the robot that you're planning to use. To set up a stage, we first start by importing a grid asset. We have to import this grid asset so that there is a plane on which the robot can rest on. Otherwise, it just keeps on sinking. So we navigate to the grid asset by go to NVIDIA, Assets, Isaac, select the version of Isaac Sim you're working with, go to Isaac, Environments, and Grid. Now I'm planning to use this default environment, so I'm gonna drag and drop it onto the stage. Now I have a grid ready. You can rename this if you want to. Uh, other, you can keep it the same. You can keep it as it is. It doesn't really matter. Uh, Now, next thing you want to do is import the robot you're planning to work with. So go to File, click on Open, navigate to the folder where you have kept the USD of the robot that you're planning to use. So I'm already in the folder, so I'm gonna drag and drop the robot on my stage. And voila, our stage is ready. S This Husky I have, it doesn't really have a working camera, so I'm gonna create one. So to create a camera or to attach a camera sensor to your bot, what you want to do is go to Create, go to Isaac, Sensors, RGBD sensor, Intel, and RealSense camera. You can choose any other type of camera you would like, but I'm gonna work with RealSense camera, so that's the one I've chosen. Um, Ideally, you'd want to keep all your sensors and joints at the same place. That place would be your base link. So I'm going to drag this RealSense camera into the base link of my robot. So let's do that. So simply click and hold and drop it into base link. Now if I click on base link, you can see the RealSense camera there. Now, the one problem that I have is this camera is not placed properly. It is floating somewhere under the Husky. So what you can do is use the handles to move it around and position it where you would want it to be. So now that I've positioned the camera on my robot as I wanted it to be, let's test if it's working or not. So go to perspective, go to cameras, and select left. And then select right. And as we can see, the cameras are working. Now we can start building the action. Alright, so before we start building the action graphs, I would like to share OmniGraph documentation with you guys. You can scan the QR code. It will lead you to the NVIDIA website where all the documentation about OmniGraph is. So for Husky, I have four action graphs. They are ROS2 clock, driver action graph, camera action graph, and odometry action graph. I will explain the elements in these action graphs and what they are for one by one. So first one is ROS clock or ROS2 clock action graph. This action graph ensures that the Isaac Sim simulation time and the ROS2 times they are synced. You can scan the QR code on the right and it will lead you to the documentation about each block or each node that is needed to create this action graph and what uh, parameters they take in. The next action graph is driver action graph. You can name your action graph anything you would like. A driver action graph, it's something that I call it. It basically means it's an action graph that helps move my robot in the ASXM environment. Now to do this, I need four main blocks. One is ROS2 context, um, then ROS2 subscribe twist, articulation controller, and differential controller. So what happens is when you do ROS2, when you publish something on the twist topic, uh, you'll have linear velocity and you'll have angular velocities. So that you feed those inputs to differential controller, which then calculates your velocity commands, which are then fed to articulation controller. Articulation controller's job is to apply the input or the driver commands to each of the individual joints, and then it moves your robot. So first, we're going to start by creating ROS2 clock action graph. For that, what you want to do is right click on the stage pane, go to create, go to visual scripting action graph. Right click on the action graph, rename this to ROS2 clock. You would want to rename your action graphs for the sake of your convenience. So right click on the action graph, say open graph. Right. So the graph is now open. So the four elements, as I explained, are going to be on playback tick. That goes there. Then the next is Isaac read simulation time. That goes there. Then it's going to be ROS2 context. That goes there. And ROS2 publish clock. That goes there. All right. We have all the elements. No. My bad. Then tick goes to exec in. Simulation time goes to timestamp. Context goes to context. Um, Everything else is the same. And that's it for the ROS2 clock. Alright, so now we're gonna create a driver action graph that will help us move the robot. So same as before, right click, create visual script and action graph. Now drag and drop this action graph into your robot, or for me it is Husky, so I'm gonna drag and drop there. I'm gonna rename it to driver. There we go. Enter. Now we start editing the action graph. So first, I'm gonna need subscribe twist. I'm gonna need on playback tick. Let me zoom out a bit. Playback tick. I'm gonna need ROS2 context. I'm gonna need constant string. Then this goes here. Let's make these connections first. So tick goes to exec in, context goes to context, value goes to node namespace. Now you can use this constant string block to change the node namespace from default to something that you want, but I'm going to keep it to default. So once that's there, I'm going to need two articulation controllers. I'm going to need one differential controller. So the thing I noticed is the articulation controller takes joint names, and these joint names are an array or a vector of 2. You cannot feed an array of 4 or a vector of 4 to articulation controller. I tried it and it failed. So then I started feeding it a vector of 2, no, 2 joint names, and it worked. So that's why we have two articulation controller. We're gonna feed uh, the joint names to articulation controller. So we drag this. It's gonna be an array of it's gonna be a vector. Oh, what did I just do? Close. Okay. Right. So property, make an array. Yeah, it's gonna size is gonna be 2. Right. And then I'm gonna have constant token here. Right. Uh, Now the token is gonna take a value of joint names, and these joint names are gonna go to my joint name here. This articulation controller is triggered on tick, so on tick, exec in, on same thing for the other one. Let's make it up here. Uh, right. Also, it is going to take velocity command. Let me zoom out a bit from the differential controller. So let's make that connection now. There we go. Okay, same thing for the bottom second articulation controller. Make an array, track an array of 2. There we go. Input 0, input 1. Done. And this goes to joint names. Right, so now this part is taken care of. We'll start off. We still need to name the joints or feed the joint names to our articulation controller. Right, so from subscribe twist, we're gonna send a tick to differential controller exec in. Now comes the fun part. We are going to use scale to stage and from units. Now this converts, like as the name says, or as the name suggests, it scales the units from the stage uh, to and from. Uh, so the connection is going to be linear velocity goes to value here, right? Then we have a break 3 vector, one for angular velocity, one for linear velocity. We send angular velocity straight here, and then this is my angular velocity in z. Then linear velocity conversion result goes a vector, and then this x, so the linear velocity, it goes in here. Now for my robot, the wheel radius is 0.165. The wheel distance is 0.544. You would technically want accurate values for these, but right now I'm just gonna put some values as a placeholder. So let's say 380 is the max wheel speed. Linear speed is, let's say, 60,000. Angular speed, again, let's say 6,000. That is it. Let's see. Right, topic name. Okay, so if you click on ROS2 subscribe twist node, you can change the topic name over which the twist messages would be published. So let's say Husky underscore controller /CMD underscore. Well, this is the topic I want. Also, now let's take care of the joint names. So constant token 1, let's look up the names of my joints. So base link, I have front left wheel, right left wheel, rear left and right left. So I'm gonna make these my front wheels. Okay, so first is gonna be front left wheel, enter. That's my joint name. Front right wheel. That's that. This would be my rear left wheel. Enter. Let's make sure that I have that joint. Yes, rear left wheel and rear right wheel. Let's see, is it correct? this goes to there, that goes there. Okay, I think this is done. So let's check if it's working or not. So press play. Oh wait a minute, there's an error. There is an error. So let's solve this. What does it say? Go to action graph for a minute. Stop. Right, so I forgot to add the target prims to articulation controller. So target is going to be the Husky. Same thing for this guy. Target is the Husky. Select. Now press play. Let's see what's happening. What is happening here? Okay, click. Uncheck this use path thingy. Stop and play, and now it should work. So now open up a terminal, and let's, before we do any of that, let's check the topics. Do I have a ROS2 topic list? No. Okay. Well, I'm gonna do source opt humble setup up bash, and then I'm gonna do ROS2 topic list. Okay, so there we see the topic. Now let's see. I'm gonna move the robot. So this is the command. Let's zoom in on our bot and enter. And there we go. The robot is moving. So this takes care of the drive action graph. And that's it for the drive action graph. Alright, now let's move on to odometry action graph or ODOM action graph. For this action graph, you'll need Isaac compute odometry node, ROS2 publish raw transform tree, ROS2 publish transform tree, and ROS2 publish odometry. Um, you can scan the QR code for same as before. Right click, create visual scripting action graph, drag this into the robot, which is Husky. Let's rename this to ODOM and edit action graph. So as shown or as explained previously, we're going to need ROS2 context block. We need on playback tick. We're going to need read simulation. There we go. Read simulation time. Okay, okay. Constant string. We're gonna need constant string. There we go. We're gonna need Isaac compute odometry node. That's there. Then we're gonna have ROS2 publish raw transform tree. Yes. To normal transform trees. Yes. And then ROS2 publish odometry node. Oh, there we go. Right. So let's space them out. This goes here, this goes here, this goes in the middle. Right. So now let's start making connections. So tick goes here. Simulation time, we don't need that. We don't need context yet, and constant string value, we don't need that yet. But as you see here, it requires a chassis prim. So let's set that up. Chassis for my robot is this. So that's my prim. Good. Now we have taken care of that. The Isaac simulation time block, it connects the timestamps of this transform tree blocks and publish odom block. So let's make that connection. So simulation time to timestamp, timestamp of this, timestamp of this, okay, times timestamp. Then context goes to context of all four of these blocks. Context. Oh, just out of there. Okay, there we go. Oh, and also on playback tick, the oh my god. Okay, there we go. Right, so playback tick, we connect it to all the blocks. So it goes here, it goes to raw transform tree, then it goes to publish odom. Good. Constant string, it now this goes to namespace. Again, the purpose of this block is if you want to change the namespace, then you can. If you don't want to, you don't have to. Uh, it's just there for the convenience. Should I need it or right. Now let's see what else. So compute odom node. Now we need to make connections with so this compute odom node goes to raw transform tree and publish odom. So we go linear velocity to oh, is it angular? Oh, sorry. Angular velocity to angular velocity, linear velocity to linear velocity, orientation to orientation, position to position. All right. And then also orientation goes to rotation and position goes to translation. That's taken care of. Now let's configure these nodes. Let's start with the top. Let's start at the top. ROS publish transform tree. So for this one, the parent is going to be the base link, which is this select, and target prims are going to be the chassis, which is base footprint. Done. For this one, same thing. So for same thing for the second one, go to parent prim. That's going to be my base link. So select base link, select. Then target prims are usually your sensors. So for me, it's going to be all the camera, well, the left stereo camera, right stereo camera, and the IMU. So go to base link, go to camera, DS50, IMU sensor is one, yes. Same thing again. Oh no, my left camera sensor, then my right camera sensor. Oops, there we go. Right, select, and that's it. And that's it. Now next, on to the next node. This node, well, it's configured. Nothing changes. Nothing changes. Hold on. Base link is given. Context is 0. Nothing changes. Nothing changes. Um, and that's it for the ODOM node. Let's see if the ODOM node is working properly or not. So let's save this. Click play. I'm hoping there are no errors. No errors. Right. Oops, it's still moving. Control C. All right. Robot, you can stop. Okay. Press play. Okay, good. All right. Let's check ROS2 topic list. Right, now we have the new topic, ODOM, right? So let's open RViz2 and see can get a grid. Alright, so open ROS2, we can change this map to base link. Everything's fine. So the odom is working. Now we won't exactly see uh, uh, the odom is working or not until we get to the camera part. But now that we have the global status okay compared to the base link, this is kind of an indication that your odom action graph is working. And that's it for the odom part. So let's talk about camera action graph. So for camera action graph, you'll need 5 nodes or blocks. One ROS2 context, Isaac create render product, ROS2 camera helper, Isaac read IMU node, and ROS2 publish IMU node. Scan the QR codes and for more information on what each of these blocks exactly do and what parameters they take in. Um, all right, now let's get started on camera action graph. So before we begin with camera action graph, there's one thing that I want to do. So we have this left and right camera sensor and including an IMU sensor. Uh, I want to override their names without renaming the sensor. Just in so without renaming the sensor in Isaac Sim, I want to access the same sensors with different names. I can do that by uh, something called name override. So select the sensor that is, let's say, left camera. Then I'm going to go click on add, go to Isaac and go to name override. Now this is my left camera. Then scroll down. So now at the bottom here you'll see the name override tab. What I want to do there is say it's going to be my front stereo camera and it is my left underscore RGB. It's my left, yeah. So this is the name I want to give it. Same thing for the right camera sensor. Go to add, go to Isaac, go to name override, scroll all the way to the bottom, and same thing. Front stereo camera colon. It's gonna be my right underscore RGB. Enter. Uh, for IMU, I'm gonna do the same thing. Name override. And instead of IMU sensor, I'm just gonna have it named as IMU. Uh, and that's it. That right. Now we begin the actual construction of an action graph. So let's make all these windows right. Right click, create, visual scripting, action graph. You can see the new action graph is created. Drag and drop into the robots tree. It's right here. Let's rename that to camera. Enter. Now edit action graph. Now we're gonna need on playback tick. That's my first. I'm also gonna need ROS2 context. There it is. Then I'm also gonna need Isaac create render product. I have 2 sensors, also 2 of those. And I have IMU, so I'm gonna do read IMU. Okay, read IMU node. I also need the simulation time node, so let's keep it down here. Let's simulation time node, right? Then I'm going to need ROS2 camera helpers. So helper, I'm gonna need 4 of those. So 1, 2. So one is for camera info, the other is for the actual data. Same thing for the other lens. That is, so two of these will be for left camera, two of these will be for the right camera. Uh, okay, so let's start connections. Um, there we go. So on tick, it goes to create render product, exec in. I hope you guys can see that. Okay, so camera prim. So one of this is going to be my left, one of this is going to be my right. So top one, I'm gonna use the top one for left. So go select. So click on the node, then go to, you'll see inputs, camera prims, and add target. Click on add target. It'll open up a window that will let you select the target. Then you go to robot, your base link, basically navigate where your camera sensor is, or the camera sensor is. This is left, so this is my camera, and that's it. This same thing for the right camera. So on create render, click on the second create render product. Uh, on the right, and under the stage pane, you'll see input and camera prim add target. So add target, click on that. Oh, go to base link, RealSense camera, and my right camera lens. Right. I think I had to do the same thing for IMU node. So yeah, IMU node. Go to IMU. Same thing. IMU prim at target. The IMU is with RealSense camera. So click there. IMU sensor. Select. What else? All right. So this is configured. Now this camera helper, you're gonna need to uh, input frame ID and node namespace. Frame ID is basically the name of your camera. So remember we did the name override thingy. That will be your frame ID. Node namespace is pretty much the same, but instead of a colon, there will be a forward slash. Let me show you. So let's add two constant strings in here. That's one, that's two. So one of these is going to be my frame ID. One of these is going to be my node namespace. Uh, so for left camera, if I'm correct, right, I have overridden the name as this. So this is the name I'm gonna use here. This will be my frame ID. Now instead of colon, change that to forward slash, and then the constant string with the colon, you wanna connect that to frame ID. Oh, there we go. And the constant string with forward slash, you wanna connect that to node namespace. Also, ROS2 context goes to context. Render product exec out goes to there. Render product path goes there. Oh, come on, there we go. All right, let's check the connections. True. Okay, so the topic name is going to be camera info. And if the topic name is camera info, the type is going to be camera underscore info. Same thing for the second one. Um, you have frame ID. Oh, so frame ID goes there. Node namespace goes there. Context goes to context. Exec tick. And of course, render product goes there. But this topic name is going to be image underscore raw, and it's going to publish. The type is going to be RGB. Now this takes care of my left camera. Now I have to do the same procedure for my right camera. So this is here, this is here. Same thing. Context first. Context goes to context. Context will go to context. That's an exec out. Exec out of create rendered product is going to go as exec in. There we go. This is right. This is for the right camera, if I'm correct. Yes. So I'm gonna have two constant strings. One for frame ID. Frame ID is with colon. Remember that, at least for the sake of this video. And node namespace is with forward slash. Okay, amazing. Let's go here. Let's go here. Frame ID. Let's make sure that's frame ID. Node namespace. Namespace. Then frame ID. Okay, that is it. Okay. So for right camera, the topic name is again, first one is camera info. If the topic name is camera info, the type is going to be camera info. Same, let's check if the top it's going to be image raw and type it same. That's fine. Okay, this takes care of that part. Now let's take care of the IMU node. So IMU node, the exec tick goes in. What else? IMU prim. I've already attached IMU prim. Okay, and then I think I need ROS2 publish IMU. ROS2 publish IMU. Okay, simulation time goes here. No, angular velocity goes to angular velocity. Linear acceleration goes to linear acceleration. Sensor orientation goes to orientation. We don't connect this sensor time to anything. Tick goes here. All right. I think, okay, topic name is, okay, frame ID. Okay. So on ROS2 publish IMU, the frame ID it's sim IMU, which is wrong. The frame ID you want there is base link. Or actually, instead of base link, have it as IMU, and then let's change the topic name as front serial camera IMU data and save. Let's see. Let's see. Oh, context. I'm missing a context. There we go. I don't need frame ID and node namespace for this one. Node is correct. Oh wait, the rendered product path is not connected. Let me connect that. So that goes there. This goes here. I think this is it. So save. Minimize. Okay. Alright, so let's check if everything works. So what you're gonna do is press play. Open a terminal. Okay. Right. Let's see. Let's do topic list. Alright, so all the topics are being published. Let's open RViz and see if the camera is working. So RViz is open. Okay. Oh, wait a minute. Wait a minute. Alright, changed fixed frame to base link. Everything's fine. Go to add by topic, and let's see what the left camera is seeing. So image. Okay. And there we go. The left camera is let's compare this to whatever we're seeing from the Isaac Sim left camera. Okay, so this is what we see on Isaac Sim, and this is what we see in RViz. I would say it's pretty much the same. So now we know the cameras are working. Let's close this. Okay, let's go back perspective. Right. Uh, let's see if um, the driver is working. So for driver, we'll have to go. Uh, let's see history. Okay. So for driver, I'm gonna run this command, 1610.1. This. So go here. 1610. And there we go. Our robot is moving. So now we know that all the action graphs that we have built, they're working. And that's it for this video. Thank you so much.